You've seen a video over the weekend finding all of the factors of a number. What I want to do now is take a number and actually find the prime factorization of it. So I'm just going to find out what prime numbers go into another number. So I'm going to start out with something we've seen before. I'm going to start out with 30. And now what I do is I create what I call it upside down division. So it's instead of looking like a regular division symbol, it's upside down. And what I do is over in this section here, in this column, I only put the prime numbers that go into that number. So I'm going to start out with, because it's even, so I usually start out with 2. And then how many times does 2 go into 30? 15 times. And I use another upside down division box. So 2 is not going to go in there, but another prime number. That's really key that I'm only using prime numbers right here in this column. That 3 goes into 15. It goes in 5 times. Again, I make another upside down division symbol. What's a prime number that goes into 5? Well, there's 1, but that's not prime. We know that. So I have 5 that's going to go in, and I'm left with 1. When I get to 1, the key thing for me here to remember is that I am all done. So when you get to 1, you are all done. So just notice here again that all of these numbers here are prime. This 2, 3, 5, all these factors of 30 are prime. So what's that saying to me? It's saying that instead of saying 30, I could say that that's the same thing as 2 times 3 times 5, which we've done on our licorice factory sheet. This is just a different way to do this that I feel like is very, very organized because all of my prime factors are just in this section here, and I know how to find them really easily. I also really like that this here tells me, this 1 at the end tells me that I'm all done, I'm all finished. Let's pick another one this time. Let's pick 48. So again, over here, upside down division, all the numbers in this section here are all prime numbers, so I have to remember to do that. So 48 is even, so I'm going to put 2 here. 2 goes into 48. 2 goes into 48. I just want to change the color. 24 times, so I'm going to put my 24 here. 24 is still even, so another upside down division symbol. I'm going to have 2 go into that. 2 goes into 24 12 times. So all I'm doing is just dividing again and again and again. I have 2 that's going to go in there. 2 goes into 12 6 times. 6 is even again, so I'm going to have 2 go in there. I'm left with 3. Now what I want to do is I want to be able to ask myself what prime number goes into 3. And the only one is 3. And then 3 goes into 3 one time. So just as a reminder, when I get to that place where I can see that 3, but when I'm done with a 1 at the bottom, that means that I am all done. So now what I'm going to do is I'm going to take my prime factorization here with all of these factors, and instead of saying 48 now, I'm going to say 2 times 2 times 2 times 2 times 3. So there are 1, 2, 3, 4 2s, 1, 2, 3, 4 2s, and then the 1, 3, all finished. What I'm going to do this time is take the same number and put different factors into it first, and then see that we still get the same thing. So let's take the number 20. I'm going to say that it's even, so on this approach over here on the left column, I'm going to go by 2. So 2 goes into 20 10 times. 10 is still even, so I'm going to put in a 2 here, and I'm left with a 5. 5 is only divisible by 5 and 1, so I have a 5 there and a 1, so I know that I am done. So 20 is also equal to 2 times 2 times 5. Over here in the right column, what I'm going to do, just to prove that. So 2 times 2 is 4, and 4 times 5 is 20. We've done that. What I'm going to do over here instead is I'm not going to start with a 2, I'm going to start with a 5. And I'm going to say 5 goes into 20. How many times? It goes in 4 times. 4 is even. So it's going to go, I'm going to put a 2 into it. 2 goes into 4 2 times. 2 goes into 2 1 time. And again, the 1 means that I am done. So here, 20 is equal to 5 times 2 times 2. 5 times 2 is 10, times 2 is 20. So check out that even though I started in a different place, here I started with the 2, here I started with the 5, but as long as all of these numbers here that I'm talking about in the left column, as long as these are all prime numbers, it's okay, because I end up having 1 5 and 2 2s, 1 5 and 2 2s, 1 5 and 2 2s, and the order doesn't matter. All right, so now try the homework and a sheet, and if you have any questions, just post them on Edmodo. Otherwise, I'll see you tomorrow.